Good morning and welcome to today's class. Today's class is a continuation of our previous classes on SURDS. In today's class, we shall be looking at divisions of SURDS. At the previous classes, we have dealt with the following objectives. We have been able to differentiate between rational and irrational numbers. We have also been able to apply the rules of addition and subtraction in solving SURDS problems. We have also looked at multiplication of SURDS. And in today's class, we shall be looking at the divisions of SURDS in solving SURD problems. Before we go into division of SURDS, let's look at the solutions to the assignment I gave you in the previous class. In the previous class, you were asked to simplify the following: 4 root 2 all squared, bracket root 5 squared, down to 11 root 3 all squared. I shall be giving you the solutions to the assignment I gave you at the last class. Bracket 4 root 2 squared can be simplified to be 4 squared times root 2 squared. And the square root of a square is said to be that number, so that this becomes 16 times 2, and this is said to be 32. Number 2, root 5 squared. Square will cancel the square root, and you're left with what? 5. So 5 is your answer. 3, 2 root 3 squared. You have to square 2 and square root 3 at the same time. This becomes 2 squared times root 3 squared. Square cancelling out square root. This gives you 2 squared is 4, and 4 times 3 is equal to 12. Number 4, you have bracket 7 root 2 squared. Square of 7 is 49, so this becomes 49 times root 2 squared is 2, and this gives us 98. And question number 5, bracket 11 root 3 squared. Square of 11 is 121 times square of 3 is 9, and this is going to give us 9 times 1 is 9, 9 times 2 is 18, carry 1, 9 times 1 is 9 plus 1 10, and this is your answer. So kindly confirm your answers from the last assignment to the answers I got, and do the necessary correction where necessary. In today's class, we shall be looking at divisions of SURDS. And we said when a SURD occurs as the denominator of a fraction, the best thing to do is to rationalize the denominator. Now, what do we mean by to rationalize? To rationalize means to turn an irrational number of the denominator of a fraction into a rational number. And how is that done? By multiplying both the numerator and denominator by the SURD, which makes the denominator rational. For example, if you have the denominator appearing, or if you have the denominator to be an irrational number, for example 1 divided by root 2, you will have something like 1 divided by square root of 2 is 1.414 something something something, and this is said to be very difficult if you are dividing without the use of calculator. It's very difficult, and so we don't need things like this in mathematics. And in order for us to make it easier to work with fractions like this, or to work with an equivalent fraction like this, we do what we refer to as rationalization. That is, making the denominator to become a rational number. And how do we rationalize? We say by multiplying both the numerator and the denominator by a factor that will make this denominator to become a rational number. But why do I need to multiply the numerator and the denominator. You will agree with me that when you multiply anything by 1, it does no change to that number. For example, 1 times 1 is 1. 2 times 1 is still 2. Any number multiplied by 1 is still that number. 0 multiplied by 1 is 0. So, we multiply by 1. That is why we say you multiply the numerator and the denominator by the rational number. For you know that the square of a square root is 1. To rationalize root 2, we have to multiply both the numerator and the denominator by root 2. Why root 2? This is because if I multiply 1 over root 2 by root 2 over root 2, which root 2 over root 2 is also said to be 1, and I told you that whenever you multiply any number by 1, it does not change to that number. So multiplying 1 over root 2 by root 2 over root 2 makes this to be equal to root 2 over root 4. And just like I told you, this root 4, it becomes a perfect square, of which this can give us root 2 over 2. By doing this, I have rationalized the denominator. Okay? So it is only root 2 that I can multiply with root 2 to make it a rational number. Otherwise, if you should multiply by, let's say for example, root 3, if you should multiply 1 over root 2 by root 3 over root 3, it makes the problem to become more complex. For you will have root 3 over root 6. So it is not simplifying the work for you. So you need to multiply it by root 2. For the square of a square root is that number. So when you do that, it makes it a rational number. So it has rationalized that number. Now you only multiply by itself or by the denominator when you are working with one-term expression. For example, root 2. When you are working with a two-term expression, then I'll show you what to do. But we are still dealing with a one-term expression. So let's take some examples. That we should rationalize the denominator of the following. A, we have 1 over root 3. So we can rationalize 1 over root 3 by multiplying both the numerator and the denominator by the denominator. And what is the denominator? The denominator is root 3. So you multiply the numerator by root 3 and you multiply the denominator by root 3. So when you do this, 1 times root 3 gives you root 3, while root 3 times root 3, you may call it root 9, or you may say root 3 squared, of which the square of a square root is still that number. So this is equal to root 3 over 3. Now by doing this, you have rationalized the denominator. That is, making the denominator to become a rational number. And by this, you can call it to be 1 over 3 times root 3. Here you can simplify it to be 1 divided by 3 is 0.33333 root 3. So this can make it easier without the use of calculator. So we rationalize denominators so as to be able to make our vision more simpler. Example 2, root 5 divided by root 2. We also multiply both the numerator and the denominator by root 2. And when you do this, this gives us root 10 divided by 2. For root 2 times root 2 is equals to 2. Note this, when you multiply, when a number or an irrational number multiplies itself, it gives you the rational number. Root x times root x is x. Root 1 times root 1 is 1. Root 2 times root 2 is 2. And so on and so forth. C, 20 divided by root 5. This can be said to be, you multiply 20 by root 5 divided by root 5. And this becomes 20 times root 5 is 20 root 5. while root 5 times root 5 is said to be 5. Now you simplify it to its lowest form and you discover that 5 is a multiple of 5 and 20. So 5 into itself is 1, 5 into 20 is 4. So this becomes 4 root 5, which you can easily multiply. Once you know the value of root 5, you can then multiply it by 4 and it gives you your answer. Next question, we have 32 root 2 divided by root 8. In this example, I will first of all simplify the denominator because it is not in its basic soft form. So you have to reduce it to its basic soft form before you rationalize. So this becomes, but you can still rationalize before you do that. Okay, so whichever way you take is perfect, it's still good. I'm going to reduce it to its basic form before I rationalize. So this is equal to 32 root 2 divided by 2 root 2. For root 8 is said to be 2 root 2. Now we can simplify. 2 into itself is 1. 2 into 3 is 1, remainder 1. 2 into 12 is 6. And our answer is, okay, root 2 can still divide. So root 2 divides itself. And this becomes 16. So when you simplify, you will discover that it will divide itself. And that's what happens. Or what happens if I decide to rationalize before simplifying? This becomes, we'll have something like this: 32 root 2 over root 8 times root 8 over root 8. Now this is going to give me 32 root 16 divided by 8, and root 16 is said to be 4. So we have 32 times 4 divided by 8. 8 into itself is 1. 8 into 32 is 4, and this is equal to 16. So you will see I arrive at the same answer, but this tends to be shorter. Next question, we have m root n divided by root m. Also, you multiply by the denominator, which is root m, divided by root m, and this becomes m root n times root m is equals to m root mn divided by m. For the square of the square root is that number. So this is m, and m will simply cancel out itself, leaving you with root mn as your answer. Kindly like this video if you've not done that, while we encourage you to subscribe to our channel as well as to on the notification button so as to be notified whenever a new video is being uploaded. We also recommend that you share this video to your friends and classmates so that they can also benefit from this project. We shall now take more exercises on rationalization of SURDS. We are asked to simplify the following. 1. 7 root 7. So we are going to multiply both the numerator and the denominator by root 7. So this becomes root 7 divided by root 7. Multiply out the numerators, divide by the denominators. So 7 times root 7 gives us 7 root 7 divided by root 7 times root 7 is root 7 squared, which is 7. So 7 will cancel out 7, which is equal to root 7. Now note, you cannot divide root 7. You cannot tell me root 7 divided by 7 is maybe root 1. No, it's not possible. Okay, now you divide rational numbers by rational numbers and irrational numbers by irrational numbers whenever you are dealing with SURDS. So take note of that. Question 2. 12 divided by root 3. You multiply both the numerator and the denominator by root 3 so as to rationalize the denominator. So 12 times root 3 is 12 root 3 divided by 3, and you can now simplify for rational to divide rational. I discovered that 3 is a multiple of 3 and 12. So 3 into itself is 1, 3 into 12 is 4. So this gives us 4 root 3. Question 3, 18 divided by root 6. You can join me in doing this. We then multiply both the numerator and denominator by root 6. So this becomes times root 6 divided by root 6. You know root 6 cannot be simplified. Root 6 cannot be simplified further. It is in its basic form. So you leave it that way. And you multiply 18 times root 6 gives us 18 root 6 divided by 6. And 6 is a multiple of 6 and 18. 6 into itself is 1. 6 into 18 is 3. Leaving us with 3 root 6. 4. 2 root 5 divided by root 2. We multiply both the numerator and denominator by root 2. And this gives us 2 root 5 times root 2. We have 2 root 10. While root 2 times root 2 is said to be 2. 2 will cancel out itself, leaving us with root 10. Root 10 cannot be simplified any further. 5, we have 3 root 2 divided by root 10. You multiply both the numerator and denominator by root 10. And when you multiply the numerator, this gives you 3 root 20 divided by 10. There is no factor that can divide 3 and 10, so you still reduce root 20 to its basic short form. This will give you 3 times 2 root 5 divided by 10. So 2 can divide itself and 10 5 times, leaving us with 3 root 5 over 5. Take note, this 5 cannot divide the 5 under the square root sign. Some students are fond of doing that, so please stop it. It is not mathematical. Thank you. Question 6. We have 9 divided by root 18. I'll have to simplify or express root 18 in its basic short form so as to make the work simpler. This becomes 9 divided by 3 root 2. And now to rationalize, we can still break it further because 3 is a multiple of itself and 9. So 3 into itself is 1, into 9 is 3, leaving us with 3 divided by root 2. We can then rationalize by multiplying by root 2 divided by root 2. So this becomes 3 root 2 divided by 2. And we leave it at this point. Now, you can simplify it to get a decimal if stated. Otherwise, it's best you leave it in this form. Number 7, 20 divided by root 50 will also express 50 in its basic short form before we rationalize. This is equal to 20 divided by root 50 can be said to be 25 times 2. That's 5 root 2. So this becomes 5 root 2. And then we simplify. 5 into itself is 1. 5 into 20 is 4. This becomes 4 over root 2. And 4 over root 2 can be rationalized. So you have 4 over root 2 times root 2 over root 2. This becomes 4 root 2 divided by 2. And 4 root 2 divided by 2, you agree with me that 2 is a factor. So we have 2 root 2 as our answer. Kindly like this video if you've not done so, while you are being encouraged to subscribe to this channel as well as to on the notification button so as to be notified whenever a new video is being uploaded. We also recommend that you share this video link with your friends while you use the comment section to interact with us and let us know how much you appreciate our project. Question A. We have root 2 plus 1 over root 2 minus 1 over root 8. In this exercise, I'm going to simplify by looking for the LCM. Thereafter, if it gives me a fraction where the denominator is an irrational number, then I go ahead to rationalize. So simplifying first will just be the best for you. So this is divided by 1. I'm going to simplify this to be root 2 over 1 plus 1 over root 2 minus 1 over 2 root 2. For root 8, it's said to be 2 root 2. So this is equal to, now looking for the LCM. The LCM of 1 root 2 and 2 root 2 is said to be 2 root 2. So this becomes 2 root 2 as the denominator. If you are still having issues with fractions, I advise you go back to watch our previous classes on fractions, and this will enable you to understand what we are doing. 2 root 2 divided by 1 is 2 root 2. 2 root 2 times root 2 is said to be 2 root 2 squared plus 2 root 2 divided by root 2 is said to be 2, and 2 times 1 is 2 minus 2 root 2 divided by 2 root 2 is 1. 1 times 1 is 1. You agree with me that the square of the square root is that number. So this will be equal to 2 times 2 is 4 plus 2 minus 1 divided by 2 root 2. So this is equal to 4 plus 2 is 6. 6 minus 1 is 5. So we have it to be 5 all over 2 root 2. At this point, we can now rationalize the denominator, that is by multiplying both the numerator and the denominator by 2 root 2. So we have 2 root 2 divided by 2 root 2. You can as well divide by root 2 only, and it will still rationalize the denominator. So this is equal to 10 root 2 divided by 4 times 2. For 2 times 2 is 4, root 2 times root 2 is 2. So this is equal to, I will first of all simplify. 2 can divide, 2 into itself is 1, 2 into 10 is 5. So we have it to be 5 root 2 over 4. So this is how to simplify. What I did was to first of all sum up the fractions by looking for the LCM, and thereafter I rationalized the denominator. Question number 9. Now the higher you go, the tougher it becomes. We are asked to simplify this. I would advise that, just like I always do, express each of the terms into their basic sort forms, and automatically most of them may cancel out themselves. Thereafter, you rationalize whatever you have. You can as well rationalize at this point, but it's going to be cumbersome for you to handle. I prefer simplifying it so as to make it easier. So, expressing each of them in their basic sort form, we have root 18 to be 3 root 2 times root 20 will be 2 root 5 times root 24 is said to be 2 root 6 divided by root 8 is 2 root 2. Sorry, 2 root 2, not 3 root 2. 2 root 2 times root 30. Root 30 cannot be expressed in its basic sort form, but root 30 is also said to be root 5 times root 6. Now I did this so as to be able to simplify them with something like numerator. All I did was simply manipulating the rules of sorts. So now you discover that something can do. 2 is a factor, can divide. Root 2 can do same. as well as root 5 and root 6. So when you multiply out, it gives you a rational number. So this is equal to, what is left is 2 times 6 at the numerator, 2 times 3, and that will be 6, divided by nothing at the denominator. So we have our answer to be 6. So you see what simplification can do. When you simplify it, there's no need rationalizing it again. Question 10, we have 12 divided by root 24 minus root 6. Simplifying this, now you will discover that the denominator is a two-term expression. So what we are going to do is, we are still going to simplify it, okay? Keep calm. Simplify it and see what will happen. This is equal to 12 divided by root 24 is said to be 2 root 6. So 2 root 6 minus root 6. Can you see? They are now like terms, so you can subtract. So this is equal to 12 divided by 2 root 6 minus root 6 is said to be root 6. Then you can rationalize by multiplying both the numerator and denominator by root 6. And this is equal to 12 root 6 divided by 6. 6 is a factor. 6 into itself is 1. 6 into 12 is 2, leaving us with 2 root 6. Question 11, we have root 3 times root 18 times root 39 divided by root 24 times root 26. So without fear, I'm going to simplify, okay? Because I know definitely it will make my work easier. So this becomes root 3 times root 19 is said to be 3 root 2 times root 39. 39 is said to be a multiple of 3 and 13. So let me simplify it and see if something will come out from there. So this becomes root 3 times root 13 divided by root 24 is said to be 2 root 6 times root 26 can be said to be 2 times 13. So I have root 2 times root 13. Yes. So if you look at it, something can divide. Now, root 13 will divide itself. 2 root 2 will divide 2 root 2. Now, watch this. I can still simplify root 6. And this is equal to, what I have here is 3 times 3. Okay, root 3 times root 3 is root 9. And root 9 is 3. So this becomes 3. And that is 3 times 3 divided by 2 root 6. So this is equal to 9 root 9 divided by 2 root 6. Yes. So I can then rationalize this. 9 divided by 2 root 6 times 2 root 6 divided by 2 root 6. And this is equal to 18 root 6 divided by 2 times 6. So simplifying this, you have 6 can go. 6 into itself is 1. 6 into 18 is 9. So this gives us 9 root 6 divided by 2. Please, on no account should you divide root 6 by 2. Please, Biko, Mbok, it is not divisible. You cannot do that. So this is the simplest form you can express this. Question 12, we have 2 divided by root 27 minus 2 over root 3. Also simplify, expressing root 27 in its basic self form. This becomes 2 divided by 3 root 3 minus 2 divided by root 3. The LCM, you will agree with me, is root 3. So root 3 root 3 is our LCM, and 3 root 3 divided by 3 root 3 is 1. 1 times 2 is 2 minus 3 root 3 divided by root 3 is 3. 3 times 2 is 6. Okay? So this gives us 2 minus 6 is minus 4 divided by 3 root 3. So let's rationalize. Multiply both numerator and denominator by root 3. If you multiply by root 3, it is still okay. If you multiply by 3 root 3, it is still okay. The aim is to rationalize the denominator, and this will still go. So this is equal to minus 4 root 3 divided by 3 times 3. And this is equal to minus 4 root 3 divided by 9. This is our answer. So you can't simplify it more than this. Coach, don't do it. I beg you. This is the simplest form it can go. Don't convince yourself that 3 is a factor of root 3 and root 9. It is not possible. Question 13. We have root 3 over 24 times root 8 divided by 26. Okay, we use the rules of SURDS, okay, and go straight ahead to multiply. So this is equal to root 3 over 24 times 8 over 26, and this can be simplified to be equal to 8 is a factor of itself on 24 by 3. Okay, so 3 into itself is 1, into this is 1. So this can be said to be equal to root 1 over 26. And root 1 over 26 is equal to, I can simplify this to be root 1 divided by root 26. And square root of 1 is 1. So this can be said to be 1 over root 26. So rationalize the denominator by multiplying both the numerator and denominator by root 26. And this is equal to 1 times root 26 will give us root 26 divided by 26. Ladies and gentlemen, this is your solution. Kindly like our videos if you've not done that, while we encourage you to share the links with your friends and classmates so that they can also benefit from this program. Use the comment section to let us know how you feel about this video. You can give us a thumbs up, tell us it's good, tell us, okay, there's a mistake in this area, and somebody will be there to attend to you. If you have not subscribed to this channel, kindly do that, and on the notification button so as to be notified whenever a new video is being uploaded. Question 14 says 6 divided by root 18 minus root 2. So this can be simplified to be 6 divided by 3 root 2 minus root 2. When you simplify this further, you're going to have 6 divided by 3 root 2 minus 1 root 2 is said to be 2 root 2. So we have 2 root 2, and 2 is a factor of 6 and 2. 2 into itself is 1, 2 into 6 is 3, leaving us with 3 divided by root 2. So this is equal to, when we rationalize, we are going to have 3 divided by root 2 times root 2 over root 2. So this is equal to 3 root 2 divided by 2. And this is your answer. Just like I said, root 2 is not a factor of root 2 and 2. Before you go ahead and divide this, it's not possible. So please don't do that. Question 15. 5 root 7 times 2 root 3. This is equal to, you multiply 5 times 2. 5 times 2 is 10 root 21. And cannot go further. So this is what you get. You can simplify it further. That brings us to the end of today's class. In today's class, we have looked at the division of SURDS. And we said in order for us to divide SURDS, we do what we call rationalization. By rationalization, we mean making an irrational denominator becomes a rational number. And that is what we have done in all the examples I have been solving since. But before we go, let me give you an assignment. You have to simplify root 3 plus 1 over root 3 minus 1 over root 3. What you are expected to do is to first of all simplify them by expressing them in their basic SURD forms. And thereafter, if the denominator is still an irrational number, then you can rationalize by multiplying both the numerator and the denominator by the denominator. Thank you for being attentive in today's class. We advise you to like this video as you watch, while you use the comment section to interact with us on issues you are not clear on. We also advise you to subscribe to our channel if you have not done that, as well as to on the notification bell so as to be notified whenever a new video is being uploaded. You can invite your friends and classmates by sharing the links to them so that they can also benefit from this class. In today's class, we have been able to look at the third objective, which says division of SURDS in solving SURDS problem. Thank you for your attention and see you in our next class, where we shall look at the concept of conjugate binomial SURDS. Thank you and do have a nice day.